3, 2, 1.
I have to make sure. Okay.
2, 3.
Hi, Olivia. Oh, nice, nice. You got a warm welcome from your crowd. Well, no, but I'm recording it, so she will get it. All right, so the first one, they made a solution of IKI called potassium iodide, guys, and it's the one that looks like in all the instructions, they always say, make it about as the color of beer. Luckily, we watch football so that we know what that looks like. And then they put cornstarch in their little semi-permeable membrane and put it in. This is the formula for IKI, for potassium iodide. Usually, it would be written together, but when you put it into solution, it's always written as IKI. And this is the formula for cornstarch C27H48O20, a typical carbohydrate, carbons, hydrogens, and oxygens. And you put it in there. This is, when they put it in, it was kind of a translucent, kind of a cloudy. It wasn't really clear, but it was kind of cloudy. It wasn't transparent, but didn't really have a color to it. And this was kind of beer colored. And when you put them together, if you actually just mix them, you would get a purple color that would actually look like black. So you can tell where they have mixed. There we go. Okay, so answer number 1, this one everybody answers here before we look at them. Which substances do you predict will move across the membrane? Your choices are cornstarch or IKI. And why? Why do you think that one will move and the other? This one isn't a, well, I can't believe you got that one wrong. You're reasoning through and you're giving me an idea of what you think. And then we will actually get it and you'll get to see which did move and how, and the group A will show you and explain it to you. Exactly. Are you group A?
Yeah.
Yeah. Yep. You will.
What does it mean by moving? Oh, yeah.
If you look at this, one of it is the IKI going to move across this membrane this way, or is the cornstarch going to move across this way? All right, Colton, you can put it on her, but I was hoping we have no idea is not a good answer. The pressure is really on group A. They should know, right?
No.
Don't break, please. No, it's broken. I'm getting mad. Oh, yeah. I'm not gonna lie.
That's a nice pencil.
I know.
Oh, and we just were bragging on Friday about how you've had these pencils for years.
3 years.
Yeah.
Till I got hit.
Oh my goodness.
Okay. I hurt myself.
Wait, where's our thing?
Not in my room.
I hurt myself in the weight room. That's why. Maddie, did your pencil break?
We'll fix it. We'll fix it. All right.
I let Haley use one of them this year, and then she lost it.
Oh no. Oh no.
There's 2.
Oh.
Shut up. That's your girlfriend.
Okay.
Group like that.
Group A, which do you guys predict? Which is going to move? IKI or cornstarch? Cornstarch. We got one corn. Who's B? Who's group B?
We are. Yeah.
All right. That's good.
Dang, I don't actually know. Yeah,
Well,
wait. Yeah.
Okay. Which, your group, which do you think is gonna move? Cornstarch or IKI? Okay, cornstarch. C, that's you guys. Which did you say? They went with the IKI. All right, we got 3 cornstarch and 1 IKI. Let me get, what, yeah, let's go through. Why do you think the cornstarch? Group A, why the cornstarch?
I said it was thinner. Like,
It was what?
it was a thinner liquid.
Okay.
Wow, yeah,
B,
just-
why do you guys think the cornstarch?
I thought it'd be easier for the cornstarch to leave the thing than to go into it. The sausage.
Why, what would make it easier?
I don't know, I just thought about it, I don't know.
Well,
We
like
don't
you-
actually know. We just put it down.
Sometimes it just comes to you.
Yeah, it's
Yeah.
just, the intelligent in him.
And why do you think IKI? Okay, it's more that, the other did have a little bit of floaty stuff in it that gave it that color. Why did you guys think cornstarch?
We have no idea.
All right, let's,
No, I don't. I don't have.
You're at it.
I don't. I have 0.5. 0.5 what? What's that talking to you?
Wow. So rude.
This shit laughs at me that my pencil is broken. She's so mean to me when all of these are here.
all right, and
Well, it
I
only
need to
makes
leave your shirt
sense.
next.
let's show. See if we can,
Wow.
whoa, it's gotta be this way. That's what you see, and actually, sorry, can you turn the lights on? Look at that quick first step. Oh, he's got no competition now. Sorry, Olivia, he got the lights.
Huh.
All right, this was a brown colored, and you can see the string still has some brown stain on it. That was in there, that was stained by the iodine. But if you look at the sausage that was clear, the sausage is now
Not clear.
purple. Yeah, no, it is the purple. So which way did the stuff move? In. It was the IKI that moved in the starch. And the reason why IKI, there are 3 atoms. All there are 3 atoms in IKI. Here there are, oh, now you're gonna make me do math. 75, 95 atoms in one starch molecule, only 3. This one's a much, much larger, that's why I gave you that, not that I'm saying, oh, you should have seen that, but that's why I did write the formula up there. 95 different atoms and only 3, so it's much easier, just like in the demonstration that I had here, the smaller ones could go through, the bigger ones can't. Now, why is it not still brown on the outside? Because iodine will disperse and it actually evaporated out. So it moved in, but the rest of it, this still should have some in it. It's not all gonna move into there. It left, but you can tell that there was iodine there because the string is a different color. So this one was the easy one, no measurement involved. You can just see immediately that it was purple. I'll leave this here if you want to take a look at the purple sausage. And how do you know? Because of the color change that it changed to purple inside the sausage. There is no color on the outside, so none of the starch made it out, which means that they also did a nice job of sealing the sausage. None of it leaked.
How do you spell sausage?
S-A-U-S-A-G-E, sausage. I don't know that it's actually that. We could call it a cell, but. Okay, part B. Part B, they took corn syrup and put it inside the cell. We'll call it a cell. You want to call it a sausage, you can call it a sausage, but inside the cell, they put corn syrup, and then they had pure water on the outside. All right, so that, keep that in mind, what they did. You have that on your paper. Turn to the next one. Name the type of solution. Corn syrup on the inside, pure water on the outside. What type of solution? Your choices are isotonic, hypotonic, or hypertonic. Those are the three tonics you've got.
What was it? Like, what was the solution?
It's the page before you got it, but it's corn syrup on the inside of the cell, pure water on the outside of the cell.
I know it's three choices.
Isotonic or hypertonic. Well, you're not actually guessing. This one isn't a guess. You know what's going on. So if you need your notes, you can look it up in your notes. This isn't, this one is no, I have no idea. That's not a legitimate answer anymore. That ship sailed.
You're not cool enough to look at my notes.
Whoa, whoa. Remember, that's not till English that you lay down the law.
That one was a guess. This one's an educated guess. Okay.
Hypertonic is when there's more stuff on the outside of the cell than inside. Isotonic's when it's the same. And hypotonic is when there's more stuff inside the cell.
It's literally in my notes.
I
right
have it
now.
written down.
You're
Whoa,
just giving me a
whoa,
look.
whoa. I'm sorry,
I'm not
Olivia. Nothing has changed.
Nope.
All right.
Shut your mouth.
What direction do you predict that the water is going to move? In or out or stay the same?
What was the thing in the sauce? Probably outside.
Okay. Is it going to move in or out?
Wait, is this like?
Let's go. Well, hopefully not. Hopefully not. D. Group D, what do you think? Which direction is the water gonna move?
I think
We take, drop this in there. Is water gonna move into it? Water gonna move out?
Wait, what do you mean water?
Like water. Corn syrup has a lot of water in it. So it will have it. Which direction is water going to move? Remember, let me give you a hint on this. Water always moves from what concentration to what concentration?
Like a.
This is one of those teacher things where there's only one answer, and I think that it's so obvious.
Say it again.
In the concentrations, the gradient always moves from blank concentration to blank concentration. Right, then that's correct. We usually say high to low, but she has, I'm giving her, it's not
Okay.
scripture, so it doesn't have to be. That's Friday. And then she's pointing a gun at me again.
I put my finger down.
Okay, so it should go from high concentration, low concentration. Where is, let me bring the, whoops, come along with that. Where's the high concentration? Inside the cell or outside the cell? Of water,
Outside.
Outside. High concentration, remember we're talking about with osmosis, water. So high concentration outside, low concentration inside. What direction should it move? In. All right, so hopefully we got this in. What was your initial mass?
54.1.
54.1 grams, and now let me get that, and you guys have a 0, they do. And do you guys have a couple of pieces of paper towel, because you're gonna want to dry off your,
I don't really want to do it.
You're the one standing. You would have got up. So I was like, go
The one who
ahead.
made
Full
it so
send.
good.
Yeah. you-
And unfortunately, Houston, we have a problem.
No, is it gone? What?
No, it's in there, but
Tie it right.
the
Where did it go?
Yes.
You tied it.
I did not.
Whoa. Nobody's asking for anybody, but this was bent over the edge and there's a bunch of corn syrup in here. There's a bunch of corn syrup on the inside and also on the part that it's in where it got forced out. There's corn syrup in there. So,
Why do I have these?
all right, so they're measuring, and
Yeah, I thought he was just.
and they came up with a mass of 60.9. 60.9. So the change, oh, why did I do, well, we could do that. Plus 6.8, I think if my math is correct. Okay. For those of you following at home, they are that fast at measuring. Or maybe I just cooked the data because that oak, and then I put it over there, it's going to leap onto my table now. Yeah. Careful your stuff there, miss. We're just don't get it in. I think that's just water, but. All right. Then pick one of those. This best illustrates A, B, C, or D. That would be a fantastic.
I don't remember.
Fan-
I don't know which one we were supposed to put. Kind of got messed up.
It doesn't really, this will tell you everything you need to know, and that would be a fantastic test question. Fantastic. Yes.
The best illustrator.
Yeah.
Okay, I'm just wondering. When did we learn the math for this?
The math,
Yeah.
60.9 minus 54.1 is
Oh, no.
6.8.
But I mean, like, when did we learn that we were supposed to do that?
You measured
Well, yeah.
It's
Okay,
just,
never mind.
it's like,
what I
I'm not
lost.
sorry. You know what? I answered your question earlier, so you can't do that. I'm like putting that high.
You're what? Water. That means water is moving across the membrane.
Yeah, I know you said we were going in.
Or out, it's moving across either direction. It's not really.
so
What's my test?
My course is cell division and mathematics. Yeah, good call. Colton, I tried to sneak one by.
So it's a
Nope.
33%.
You've narrowed it down.
Hey, Colton. What did you put?
It's a-
Hey, Mr. Schmidt. what
Hate
would
to
you
say it, the other three, we talked about this chapter.
No, what did you hypothetically put?
Me?
Yeah.
The right answer.
Ah.
All right.
Are we supposed to guess?
yeah.
No, you're supposed to know.
Okay.
Okay, part C. Let's hope that this one got tied tightly. This time they put pure water inside the cell. Whoops. Whoa. Wow, we have a cell coming all apart here. That's better. All right, so this time, guys, they have a cell with pure water on the inside and salt water on the outside. So it's a turn the page to the next one. Name the type of solution and what direction will the water move. You've got that. I'll move it back here so you can look at it again as I get.
Mr. Schmidt.
Yep.
What is isotonic?
It's the same on both sides. Mature there.
No, you were gonna help us.
I don't know.
It's osmosis. Today?
Okay, and this is ABC. What was your original?
So, Jane was the only one that got that. But she lost. No, I'm pretty sure it's 28.6.
Where they go?
28.6. Pretty sure 28.6. Oh my, there's nothing like rock solid science. We have a leaking cell, we have a guess at a number. All right, so trying to dry this off so we don't measure water on the outside with it. And have you guys measure this now.
I'm so tired that every time I laugh, I cry, so.
All right. We're gonna go with their guess because it's gonna make my life easier anyway.
In a plant,
Why do you guys expect me to be smart enough?
what is 3 mean?
Oh, God.
She'd be in drama.
No.
Yeah.
You're in drama. I know. Fake it till you make it.
Hey, we do that all the time.
Wait, we do that all the time.
Don't worry about it too much, Emily. There, we'll probably just lose the number anyway.
Probably. I take it, I don't do it. No, that's not.
Wait, so,
Almost under no sense, bro.
Olivia, this is cold. Cold, Olivia.
how do you know?
Okay, so is there more solute? Where's the pure water? I mean, where's the most
In the
highest
side.
concentration? Inside. So it's the highest concentration there, low concentration out here.
Okay, so it'd be that.
It would be.
Okay, now what is this one?
That's where it's the same inside now.
Now, how do you know
In
that?
equals out.
Yeah, okay. How do you know this one has a higher concentration?
Because it's just water. This is water with salt in it.
Wait, so what is the high concentration?
I said
So this one right here. Yeah, no, is it
this
all
one?
Is there any ones without H2O? Or does everyone have H2O?
Somebody's got to have H2O.
Oh, okay.
The
said
whole
that
thing
one.
is osmosis.
Okay, that,
so-
no, it's this one.
All right. What did we get, Miss Bryson?
Maybe we do. I don't know. Wait, hold on, which one? It's 20.
Hey, I don't know that one.
Is it?
No, no,
Hasn't gone to the 1 yet? Yeah, so it's 20.8. Yeah. All right. So they got a final mass of 20.8 grams. Now do the math. Final minus initial.
I can't remember how to do it.
7.8.
Yes, 20.8 minus 28.6.
7.4, -7.4.
Negative
Yeah.
7.4.
Okay, well,
No, I got negative 7.8.
I think it's got to be an 8.
Yeah.
Negative 7.8. So it lost water. Water went out of the cell. So hopefully that's what you said was going to happen, and which makes sense because this is where the high concentration of water is. Low concentration, it's always going to go from high to low. So water's going to come out and try and dilute this. And so it's moving out. So no matter what that initial was, this worked out. So nice. And in a plant, this is known as, that's in your notes, just kind of a nice little review there. Yeah, we haven't got to photosynthesis yet. Okay, part D, you can come back to that part, and look at the time. We are up against it, so you can answer the questions for the first part for part D. If you have a balance, sorry, part D, you zeroed a balance needlessly, but it might be close at least for third hour. And we'll take that. You want to see the part A, the cell that turns purple? Look at that before I toss it. Yeah.
How do you guys say anything? You're sweet.
But don't make any mess though.
Don't lose it.
No.
Running later.
Nice.
Well,
Mine is better.
I thought Colin would be the one. I know.
Yeah.
I need-
I think I was doing
Yeah, no, you
that.
didn't
Because I don't even remember doing that.
Nice.
Take it. Not your thing. I need to take it. I'm gonna be sad. I'm not Olivia. I don't care about stupid quarter.
Wow. Wait a minute, don't call him stupid, I do. All right, Olivia. See you tomorrow, and you can Zoom at that time. Oh, she will be.